Hello everyone. Today we will be talking about plasma globes. Ignore the big metal spider. That is irrelevant. I just use this because this is the only plasma globe that I have. It is a pretty cool metal model though. And it does indeed show the Tesla coil driver circuitry, the plasma globe's driver circuitry, which will be important later. So a plasma globe is a very simple device. It is a glass globe filled with a small amount of gas, and that is a very special mixture of gases that when a high voltage is applied to it, it will glow in a very specific color, and it produces the classic plasma globe color that is very common in the industry. Um, let's go ahead and power this thing on. This thing is just powered from a simple USB. So let's go ahead and plug it into this phone charger. Perfect. Let's turn off the lights so that you can actually see it. As you can see, it's very nice, and the high voltage that's being produced by the drive circuitry is producing some lovely effects inside of this small glass ball. So what's going on here is that there is a driver circuit right here, which consists of a control chip, which switches a transistor, which switches a current in the flyback transformer, which is this big black box over here, and that switching current in the primary side causes a high voltage on the secondary side, and the business end of that is piped up into the stem of this plasma globe. And there is this plastic sheath cable that goes all the way up to the top. But you notice how there is kind of an area of glow around the tip of the plasma globe's stem. And that is a very interesting property which allows this plasma globe to work. At the end of this wire, of course, the wire is exposed. The end of the wire is connected to a small amount of very coarse steel wool, which makes a connection with a metallized paint which covers the inside of the tip of this stem. And that forms one side of a capacitor between the high voltage output and ground, which of course is the common ground of the circuit. And this high frequency voltage causes these little arcs to form, which is just a current trying to capacitively couple between the inner electrode and ground. And the reason why this particular plasma globe has several streamers that point down is because this little metal strap right here is capacitively coupled to ground, so the streamers tend to navigate towards here. And this right here is the little evacuation stem, which was used to draw a approximate vacuum in this and fill it with some other gases. And as you can see, it lights up when I put my finger to it. And indeed, plasma globes light up when you put your fingers to it because you are capacitively coupled to ground. And so if you touch the outside, it forms a capacitor between the inner electrode and you, and a capacitor between you and the ground. So current, an extremely small amount of current, flows between you and the ground. And the funny thing is that even though that there is current flowing through you, which you would normally be able to feel, the reason that you wouldn't feel it when you touch a plasma globe is because the frequency at which the transformer is being switched is so high that nerves don't care anymore. I mean, yeah, they do not respond to frequencies over about 20 kilohertz. And that is crazy because you can touch a big Tesla coil, which is switching at 100 kilohertz, and you wouldn't feel anything, at least electrically speaking. You'll still be burned because it's such a high frequency. And speaking of that burn part, if you were to hold your hand on a powerful enough Tesla coil for long enough, then you actually feel some warmth in these areas that are illuminated pink. And yeah, that's because there is a small amount of current flowing, and because the fingers are rather insulated, and they are, of course, heated by the blood. They will end up building up a little bit of heat from this current, and so your fingers would feel a little bit warm. And that is quite interesting, no?